In this section, we're on the second section of Chapter 5. We're looking at reducing exponents and radicals using properties. My goal for you today is to use properties of exponents to rewrite radical expressions and simplify your radicals. There are really three big exponent properties that you should be comfortable with for this unit. One is the product property for exponents, and then the quotient property for exponents, and the power of a power property. Think to yourself if you remember these properties of exponents. The first one, the product property, you have to have the same base. And if you have the same base, you can add exponents when you're multiplying. And quotient is kind of related to that. If you're dividing and you have the same base, you can subtract exponents. And power of a power says if you're raising an exponent to a power, you multiply your exponents. All of these come from what exponents mean. So if I'm doing like 3 squared times 3 to the third, then what that means I'm doing is 3 times 3 times 3 to the third. And what I wind up with is 1, 2, 3, 4, 5 threes. So it's 3 to the fifth, and that's why we add those exponents. You can figure all of them out from remembering what the definition of an exponent is. All right, we're going to look at fractional exponents with these properties because that's the part that's new to us, is the fractional exponents. The properties shouldn't be new to you. Okay, this looks to me like it's the product property for exponents. We have the same base and we're multiplying, so we're going to take our base and we're going to add exponents. 5/6 plus negative 1/3. Okay. Well, if we're adding exponents, if we're adding fractions, we need to have a common denominator. I can turn this into a denominator of 6 by multiplying this fraction by 2 over 2. So I have negative 2 over 6. If I add my exponents now, I get 81 to the 3 over 6. But I can reduce that fraction, so it's 81 to the 1/2. And again, what that means is what number times itself twice gives me 81? So that's 9. This problem actually uses multiple properties, but we're going to start by noticing that we have the same base and we're dividing. So we're going to start with the quotient property. So we have x to the 1 times x to the negative, not times. We're using the quotient property, we're going to subtract the exponents. So our base is x, and we have x to the 1 minus negative 1/2. We're subtracting exponents, but the exponent is negative. And then we also have y to the third. We're going to raise all of that to the 2/3 power. Subtracting a negative is going to turn into addition, and I'm going to look for a common denominator, so I'm going to do that as 2 over 2 plus 1 over 2. Oh, that's base is x. Sorry, I wrote that wrong. If I add those together, I get x to the 3/2, y to the third, and I'm going to raise all of that to the 2/3 power. So now I'm going to use the power of a power property, and I'm going to multiply my exponents together. So this becomes x to the 6 over 6, 3 times 2 and 2 times 3, and then y to the 6 over 3. And again, I can look at those fractions and I can reduce those fractions. So I get x to the 1 power, y to the 2nd power. And those are my simplified versions of those problems. Please look at the answer key for the you try problems. They're not in this video, but you can see them on the answer key. The other way that we can reduce our radicals is by using product property for radicals, which says if you have the same index and you're multiplying, you can combine that as a single product and then do the root of the product. Similarly for quotients, if we have a quotient, we can combine those as long as we have the same index on our radicals. I'm going to go ahead and use these properties, but this is what those properties say. All right, so we're going to write this in reduced radical form. And what that means is we're going to try to get perfect cubes out of this so that we can have our perfect cubes. And we're going to split this into a product of two things. So one way of doing it, and we're going to think about are there any perfect cubes that go into 16? And we know that 16 is 8 times 2, and we know that 8 has a nice perfect cube. So we're going to split that 16 so that it's the cube root of 8 times the cube root of 2. And we're using this property where if it's a product, we can split it into two separate roots. And then I'm going to look at the x's, and for the x's, I could do the cube root of x cubed, because that has a nice answer, and the cube root of x squared, because that doesn't. So the cube root of 8 is 2. The cube root of 2 doesn't have a nice answer. The cube root of x cubed is x, and the cube root of x squared doesn't have a nice answer. I can rearrange things and I can combine things that have similar roots. So these guys can be combined as a product. So we have 2x on the outside, and then we have the cube root of 2x squared as a radical. This is not the same way that we were reducing radicals before. Before, what we would do is we would make a tree out of the 16, and you can still do it this way if this way makes more sense to you. We have 16 is 4 times 4, 4 is 2 times 2, and if I look at that, the end branches of that tree, I'm looking for 3 friends, and if I have 3 friends, they can go outside together. So that's where that 2 comes from, because those 3 friends got to go outside together. But this 2 didn't have any friends, so it had to stay inside and play Xbox. And then x to the 5th, I could write as 5x's. I have 3 friends, so they can go outside. And I have 2 loners who have to stay inside. So that's the other way of reducing your radicals. You can either do it by splitting it up into perfect cubes, or you can do it by making a tree. I have some more for you to practice. I'm going to let you practice on this one. I'm going to look at this one that's a fraction, though, so I'll do that one with you. The first thing I'm going to do is I'm going to combine these x's because they have the same base. So I'm going to rewrite that as x to the 4 minus 1, because that's division. And then I have y squared still, and in the denominator, I have 125. All right, so I'm going to look and see if there's any reducing that can happen. I'm going to write this as separate things. So the cube root, oh, I forgot to write my little index here. The cube root of x to the 3rd times the cube root of y squared divided by the cube root of 125. This one has a nice answer, that's x. This one does not, so I'm going to leave that as the cube root of y squared. And 125 has a nice answer, that's 5. So this is now written in reduced radical form. This is another one where we're going to write it in reduced radical form. I'm actually looking at this and I'm thinking, well, I don't really know what these multiply to, but I do know that I could break this up into as a 2's. So 16 is 2 times 2 times 2, right? So it's 2 to the 4th. I might have said not enough 2's. 2 times 2 times 2 is 16. And 8 is 2 times 2 times 2. So when I do this, I'm going to write this as a single radical. It's to the 5th power. It's 2 to the 4th times 2 to the 3rd. And then if I look at this, this is going to be the 5th root of 2 to the 7th. Now, that means to me that I have 5 friends who can go outside, or I can think of this as the 5th root of 2 to the 5th, but then there are 2 friends who have to stay inside. So those 2 friends are going to stay inside, but this group of 2's is going to be outside together. So now this is in reduced radical form, although I'll bet you Pearson wouldn't write it as 2 squared. I'll bet they'd write it as 4. All right. I'm going to leave these, but I'm actually going to have you cross this one off for now because we haven't really talked about that yet. So those are for you to try. And I'm going to have you cross, yeah, let's cross this one off. We'll talk about reducing radicals in a minute. The next video is going to be about doing operations with radicals. So come back for the next video.